the quantity 1 plus x1 times 1 plus x2 times everything up to 1 plus xk, for k being a positive integer, is greater than x1 plus x2 plus x3 plus x4 plus dot 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 plus xn or plus xk plus 1, given that x1 dot 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 xk all have the same sign and xn is always greater than -1.
What does that mean? Well, if a and b are greater than 1, then a times b is greater than, well, I was going to say greater than or equal to, oh wait, no, we can't say that, sorry. So we're going to show that if a and b are greater than 0, then we can do this. A plus 1 times b plus 1 is greater than a plus 1 plus b plus 1. So how do we know that? Well, a plus 1 times b plus 1 is ab plus a plus b plus 1. So we can cancel these out and get that ab is greater than 1, which obviously must be true since a is greater than 1 and b is greater than 1. So if this was not true, then that would imply either one was less than 1. Well, I guess to demonstrate my point, we can say a is equal to 1 plus m, and b is equal to 1 plus n, where m and n must be positive real numbers. So then, multiplying them together, we get 1 plus m plus n plus mn. And of course, this is 1. This is a positive real number. This is a positive real number. And them multiplied together is positive and real, which means this is positive, which means 1 plus this is greater than 1. So that's case 1 done. So what about case 2? Oh, wait. Well, technically, case 1 isn't done. Sorry. So let's say now that we have the product 1 plus x1 times 1 plus x2 times 1 plus xj. So then, here's what we can do. We now know that these two have a product that's greater than 1. So this is greater than 1. And we multiply that by 1 plus x3. So then, well, not only is this greater than 1, but this is greater than 1. I'm sorry. This is greater than 1 plus a plus b plus 1. So 1 plus x1 plus 1 plus x2, which means multiplying this gives us something that's greater than 1 plus x1 plus 1 plus x2 plus 1 plus x3. Which means if we repeat this pattern, eventually we'll get something that's greater than j plus x1 plus x2 plus x3 plus dot 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 plus xj. And of course, j plus x1 plus dot 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 plus xj is greater than or equal to 1 plus x1 plus dot 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 plus xj, since j is greater than or equal to 1, since it's a natural number, which means that this is proved. Okay, so now we can actually set boundaries for case 2. So for case 2, what do we do? Well, that's when, oh crap, I forgot to specify a crucial thing about the problem. x1 through xj are all greater than minus 1. So in case 2, x1 through xj are all negative. All right, so what does that mean? That means 1 plus x1, 1 plus x2, dot, 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 1 plus xj, and of course we have the requirement on the other side that this is minus 1. These are all between 1 and 0. All right, so what does that tell us? We can still prove the same exact thing right here. A plus 1 times b plus 1 is greater than 1 plus a plus b. Plus 1, I guess. So we get ab plus a plus b plus 1, which is greater than 2 plus a plus b. So we get that, oh, right, sorry, we can't do that. So we're going to show that this has to be true. So this is just ab plus a plus b plus 1 is greater than a plus b plus 1. We can cancel out this, and ab is greater than 0, which is true since negative times negative multiplies to become positive. So that means when multiplying these together, 1 plus x1 times 1 plus x2 has to be greater than 1 plus x1 plus x2. So then 1 plus x1 times 1 plus x2 times 1 plus x3 is greater than 1 plus x1 plus x2 plus 1 plus x3. And then we can keep on going with 1 plus x4, 1 plus x5, etc., and etc. Which means that eventually 1 plus x1 plus xj is going to be less than j minus 1 plus x1 plus plus xj, which is again less than or equal to 1 plus x1 times 1 plus x2 times dot 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 1 plus xj. All right, there we go. That's it.